Okay, to get us really started into some pre-cal material, we are going to be looking this first unit at functions. We talk about functions in Algebra 2. Some of what we'll do this first unit will be review, but we definitely take it more in depth and a little bit further in pre-cal than we did in Algebra 2. So what we first need to talk about is, what is a function now? A function is something that you have defined, in a couple different ways since probably Algebra 1, if not before that. In pre-cal, how we define a function is that a function is a rule which takes certain numbers and those numbers are what we call our input. Takes those certain numbers, and once it goes in through the function, whatever that might be, we assign each of those inputs to exactly one output. How you all are used to seeing these input and output for functions is like x and y. Typically your input has been your x value, your output is your y value. So think about what you've done in previous math classes. If we evaluate an expression or a function, that typically meant that we put in a number for x, and then we simplified, and then we ended up with a number for y. That's really what input and output is. We say that and this is going to be a big focus of what we'll do here, the output is a function of the input. We say that the output is a function of the input. So typically what you're used to seeing is a function where y is a function of x. Okay. Now, you have seen many different ways to represent a function. We'll look at those 4 ways with one example to kind of see some similarities and differences. So, for some animal, this is new to me, the snowy tree cricket. I'm curious where the snowy tree cricket lives. I'll have to look that up. But anyway, for the snowy tree cricket, there is a relationship between the temperature and that bird, or cricket, not bird, the cricket's chirp rate. It says we can estimate temperature by counting chirps in a 15-second interval, then adding 40. So that information right there is a rule which we can then write as a function. Okay? It says the rule to find the temperature T, so I'm looking, there's a variable, from the chirp rate R. Now this is important. That chirp rate R is in chirps per minute. We'll have to keep that in mind. Again, this is an example of a function. So if we want to write this function first in words, it'll look similar to what we have been given, okay? So in words, we can say to estimate, we're just writing out the rule, to estimate temperature, we count the number of chirps, in 15 seconds and add 40. So that is the rule or the function in words. We can represent a function in a table. Notice here that we're given our input and our output. The output is the temperature, okay? That's what we're trying to find. The output is what we're trying to find, the temperature T, capital T. The input, that's the information that we put into the rule. Now, here's where we have to remember what that variable capital R represents. That capital R represents, remember, chirps per minute. Chirps per minute. Okay? So, let's do this. And I'm just kind of making up some input values. So let's say that we have 20 chirps per minute, 40 chirps per minute, 60 chirps per minute, 80, and then 100 chirps per minute. So now what we need to do is, with those chirps per minute, we need to figure out the output, okay? So let's think about going to our function in words. So to estimate our output temperature, we count the number of chirps in 15 seconds. So here's where we really need to make the connection between what we have in words and then what we have in our table. Remember that this is chirps per minute. So the question is, from the chirps per minute, how do we find the number of chirps in 15 seconds? How do we find the number of chirps in 15 seconds? Well, how many intervals of 15 seconds is there in 1 minute? 4. Okay, so if we take the 20 chirps per minute, divide by 4, that would give us the chirps in 15 seconds. So 20 divided by 4 is 5, and then add 40. So the output for the temperature in this one is 45. Similar thing for the next one. If we had 40 chirps in a minute, divide that by 4, we would have 10 chirps in 15 seconds. Then add 40, that's 50. I want you to take a couple minutes, stop your video, and I want you to figure out the outputs for temperature for 60, 80, and 100 chirps per minute. What we should have ended up with is a temperature of 55 degrees, 60 degrees, and 65 degrees for the chirps per minute of 60, 80, and 100. Be sure, if you are confused, that you ask about this. We'll take time in class next time to kind of go over what you did in the video, so make sure that you ask if you're a little confused on this. All right, the next way that we can write a function or represent a function is in a formula. So far we've written it in words, we've written it in a table, now we need it in a formula. So let's start with our output. T equals, okay, T equals chirps in 15 seconds. So let's think about what we did to each of our inputs. We took each of those inputs R and divided them by 4. So we could say that T equals 1/4 of the value of R plus 40, okay? That's just saying in a formula or an equation exactly what we did in the table. We took the value of R, divided it by 4, then added 40. Then finally, the last way that we can represent a function is with a graph. So what we need to do first is probably get a scale for our axes, and I'll kind of give you a clue here. If you go by 2s and make each one of those 10, our graph fits on here pretty nicely. So this is 10, 20, 30, 40, and so on. And 100 would be off just a little bit. We can do the same thing for our vertical axis. Okay, so now that we have our scale on our axes, you guys know how to plot points. You've been doing that for, oh gosh, years and years and years. The easiest way I think to do this is just take, you know, the ordered pairs from your table, plot it on your graph. So you can do that, you know, on your own a little bit here. I'm going to go ahead and plot 2045. Doing this on my iPad is a little difficult. Let's see if I get these in the right spot. 2045, I have 4050. I have 6055. I have 8060. I think that's the place. And 165. Okay. And then we can kind of do a little best fit line there. Okay. All right, so just to recap what we've done there, remember a function is a rule where when you put one number in, that's the input, you get exactly and only one number out for the output. There are 4 ways to represent a function. We can do that in words, in a table, in an equation or a formula, and then in a graph. Okay. The next page of notes, what we'll be looking at in class next time is what we call a mathematical model. And you've been using these for several years, even though maybe that hasn't been the name for it. We'll be looking at what we call function notation. We did look at that a little bit in Algebra 2. So we'll be looking at function notation. And then finally, if you last page of the notes, we'll be deciding finally whether we have a function or not. So I'm going to stop the lesson there. Just wanted to get that started so we had a little bit of time, a little bit more time in class to discuss the rest of this. So make sure you come in prepared. See ya.